Good day, students. This is our very first lesson. Topic 1, Lesson 1, Basic Geometric Terms and Definitions. Okay, let's look at our very first example. It states, consider the diagram below with parallel planes P and M. Give a name denoted in the diagram that represents the figure below. So as you can see, we have a couple of vocabulary terms that you have gone over already in your warm-up activity. The very first one is array. So if we remember what array is, it is a line that has an endpoint that goes into the direction or any direction infinitely. So over here we have an example of what the notation is for array. So let's see. I have a couple rays in my example. I have ray CA. CA has the endpoint of C and goes in the direction infinitely to the left. I also have an example here of another ray, which is DB. DB has the endpoint of D and goes in the direction infinitely to the right. If I want to give another example, I can say I also have ray CB. CB is an endpoint and goes into the direction to the right infinitely, including point B. And let's look at the next feature, which is a line. As you can see over here in our geometric notation, we have a notation for a line. So remember, a line includes endpoints that go in opposite directions infinitely. So I have a couple examples of a line here in this diagram. I can name this line AB. I can name this line CB. Or I can name this line AD. It is including all the points, or at least 2 points, and both of the sides of the lines are going in opposite directions infinitely. Let's look at the next feature, which is a line segment. So over here in our geometric notations, we have the notation for a line segment. Now remember, a line segment is a line that has 2 endpoints. It does not extend infinitely in both directions. They have immediate stops. So for example, I can state that I have line segment CD or line segment AB. Coplanar points. So remember, coplanar points are any points that are on the same plane. So I have 2 examples of those. I have points E and C. E and C are on plane P, and I have points F, D. F, D are on plane M. Collinear points. So remember, collinear points are points that are on the same line. So as you can see, we have 4 points that are on the same line. We have points A, C, D, and point B. Perpendicular line. So remember, a perpendicular line are 2 lines or 2 rays or 2 line segments that intersect and create a 90-degree angle. So we have 2 examples of those. We have line segment EC, and that intersects with the ray CA. So how do we denote that? I would write line segment EC, and the notation for perpendicular is kind of like an upside down T, and that is perpendicular to ray CA. I also have the same example over here with line segment FD, and that is perpendicular to line ray DB. The last one is parallel lines. So remember, parallel lines are two lines, two rays, or two line segments that never intersect but have equal distance apart from each other. So I have an example here of line segment EC and line segment FD. So how would I write that? Line segment EC is parallel, sorry guys, is parallel to line segment FD. Okay, so now let's look at example 2. It says, consider the following figure. We are looking at this figure to see what statements to the right are true. First statement says, line M is perpendicular through point P to plane T. So we have the line here M, and M is going through point P, which is here, and it is going through the plane T, which is here. So this is a true statement because we have the line M going through point P and is intersecting through the plane T. So we can mark that one as being true. The second one says points C, D, E, and F are coplanar in plane T. So I see points D, E, and F on plane T, but point C is not on plane T, so we cannot say that those points are coplanar. The next one says D, P, F are collinear. So I see P and F are collinear because they are on the same line segment, but D is on the line segment with point E, so that's not a correct statement. The next one says FC is longer than DF. Well, FC are not even on the same line or line segment, nor is DF, so we cannot consider this as a true statement. The last one says line segment DE and line segment PF are coplanar in plane T. So I do see line segment DF on the same plane as line segment PF, and they are both on plane T. So yes, I can say that this is a true statement. So here we are with example 3. Consider the figure below. Here we are going to find the value of x. So in this example, we're going to use the segment addition postulate, which says if I have a line segment with a point or points in the middle, I can set up an equation or an addition equation to show the value of the full line segment. So here we're going to use the SSS solving system in order for us to find the value of x. The first S represents setup. So to set up my equation, I'm going to take the parts that are represented in the figure and write it down in an equation. So the first part is MN, which is line segment MN, is added to line segment NP, and that's going to equal the full line segment of MP. The second S says that I take those parts that I have represented in my setup and replace them with the values of those parts. So the value of line segment MN is substituted as 4 times the quantity of x plus 5. And then the value of line segment NP is substituted as 2x plus 1. And then the value of the full line segment NP is substituted with the value of 39. The last S is to solve. So here we're just going to solve this equation algebraically with all the properties that are needed to find the value of x. So here I have this 4 that is on the outside of the parentheses, and we're going to go ahead and distribute that 4 to everything inside of the parentheses. So this gives us a 4x plus 20, and then we bring down everything else in our equation. Now, as you can see, we have some like terms. We have 4x here and a 2x here, and we also have a 20 here and a 1 here. So we're going to take these like terms and simplify the left side of our equation. So 4x and a 2x gives us a 6x, and 20 and 1 gives us a 21. And then we bring our 39 down. Now we have a two-step equation here. All we're going to do is use the properties of solving to solve for x. So I'm using the subtraction property of equality to get rid of my 21, and I'm left with 6x equals 18. And then I'm going to use the division property of equality to get rid of my x, and that leaves me with x equals 3. Now, with this SSX solving feature, we don't just leave it as it is. We make sure that we check our answer. We got to make sure that the answer is correct. So how do we check our answer? We plug whatever value we got back in to make sure it makes sense. So to check, I have 4 times 3 plus 5 plus 2 times 3 plus 1, and that should equal 39. So 4 times 3 plus 5 gives me 8, and then 2 times 3 gives me 6 plus 1 equals 39. 4 times 8 gives me a 32. 6 plus 1 gives me a 7. And then as you can see, we have 39 equals 39. So in fact, guys, we see that our answer is correct. Example 4. It states, if line segment AB has the endpoints A at 6, -3 and B at -6, 3, then the midpoint M of line segment AB is the origin. So here we're going to use the midpoint formula because in the problem it clearly states we are trying to find if M is the midpoint at the origin. So before we actually use this formula, we're going to label our points with the proper notations. So here I have coordinate A, which has 6, and that would be our x1. And I have -3, and that would be our y1. So that's our first set of points. And then I have -6 for point B as our x2. And then 3 here would be our y2. So before we start plugging in anything or starting to solve for anything, make sure that we have the proper labels stated in our problem. So now we can go ahead and plug in. So this right here would be represented as our setup. We set up using our formula, which is the formula for the midpoint. Now we can go ahead and substitute. So we have M times, or is, the quantity of 6, which is our x1, plus -6, which is our x2, and that's divided by 2. And then we have y1, which is -3, and then that's going to be added to +3, which is our y2, and that's divided by 2. And now we're going to solve, or in this case, we're going to simplify. So the last S can either be solve or simplify. So we have 6 plus -6, which is really 6 minus 6, which is 0, divided by 2. And then we have a -3 plus 3, which is really -3, or 3 minus 3, which is 0, and that's divided by 2. So as you can see, when we simplify, 0 divided by 2 gives us 0, and 0 divided by 2 here gives us also 0, and a point that 0, 0 is located, in fact, at the origin. So it's saying if I have these endpoints A and B, The midpoint is going to be at the origin, and of course it is, so therefore it is a true statement. Our last example, guys, example 5. It says determine whether line segment JK and line segment LM have the same length. We need to do this by justifying our answer. So as you can see here, we have what we call the distance formula, and that is equal to the distance between two endpoints on a line in a coordinate plane. So as we did before, this is going to be our S, and that is our setup. Our setup. We're going to do the second S, but before we can do the second S, like I mentioned in example 4, we have to make sure that we are labeling and identifying the points in the information that's given in the example. So let's look at JK. J is an endpoint, and I see that endpoint is at -4, 4. So we're going to go ahead and identify JK as having endpoints -4, 4, and K as having endpoints -2, 1. The second line segment we have is LM. So I have endpoint here L at -1, 1, 2, 3, 4, -4, so -1, -4. And I have endpoint M at point 2, -2. Okay, and remember we're going to go ahead and identify or label the points. So I have my first set of points here, which is x1, y1, and this is going to be my x2, y2. And I can do the same thing for my second pair of points, which is x1, y1, and x2, y2. So we just want to make sure that we are identifying the points that we have before we go ahead and use the formula to determine if they have the same length. So our setup is going to be in two parts. We're going to do it one for JK and then one for LM. So we have JK, and then we're going to substitute the points that we have for JK. So we have x2, which is -2, and x1, I'm sorry, that's not a comma. Let me erase that. That is a subtraction sign. -2 minus a -4, and that is all squared, plus my y2 for k and j are 1 minus 4, and that's squared. And then we have this all under the radical sum. So now we're in our second part for JK. We're going to do the same thing for LM. So LM. LM, we are also going to substitute for x1 and y1 and x2 and y2. So the formula says that we're going to substitute in for x2 on L and M. So I have 2, which is our x2, minus -1, and that is squared, plus our y2 is -2. Oops. Sorry. Let's try that again. -2 minus, that will give me a -4, and that is squared. And everything is going to be under the radical sum. All right, so the last one is to solve. So we have 2 to solve for JK and for LM. So let's look at JK first. We have a -2 minus a -4. A negative and a negative tells me we get a positive. And then here we have a 1 minus 4. So we can do that together. So -2 plus 4 gives me a positive 2. So that's going to give me 2 squared plus 1 minus 4 gives me a negative 3, and a negative 3 squared. 2 squared gives me 4, and negative 3 squared, which is negative 3 times negative 3, gives me a positive 9. So 4 plus 9 gives me the square root of 13. Let's see if we get the same answer for line segment LM. So I have 2 minus negative 1. A negative and a negative gives me a positive. And then I have a negative 2 minus a negative 4. Negative and a negative gives me a positive. So let's come down here. 2 plus 1 gives me a 3 squared, plus negative 2 plus 4 gives me a positive 2 squared. And it looks like we're going to have the same thing. 3 squared gives me a 9. 2 squared gives me a 4. And as we did for line segment JK, 9 plus 4, that gives me the square root of 13. So as you can see, both of them have the same distance. So that means the distance from J to K and the distance from L to M is the square root of 39. So what does that tell me? That this statement is true. Okay, so we've completed all 5 examples in the class notes. Now this is the opportunity for you to go to your class notebook in Microsoft Teams and complete the next 5 examples on your own under the You Try It in your class folder. I'll have and review these problems during our virtual class session when I see you next time. Have a great day, guys.